Hello guys, welcome back to my YouTube channel. Today we are going to solve day 9 problem on LeetCode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Okay, so guys, this is a problem of largest divisible subset. So in this problem we are going to use our DP. Okay, this is of medium level, but I will make sure that by the end of this video you guys will find this problem very easy. Okay, so now let's read the problem statement first. Okay, so in this problem we have given a set of distinct positive integers nums, and we have to return the largest subset answer such that every pair of elements in this subset satisfied this condition. Okay, so answer of I mod answer of j is equal to 0, or other way around. If answer of j mod answer of I is equal to 0, then it is also good. Okay, so if there are multiple solutions, then we have to return any of them. Okay, so this is the example 1. In this input nums is given to us as 1, 2, 3. So here you see 2 mod of 1 is 0, right? And 3 mod of 1 is also 0, but 3 and 2. Okay, so 3 mod of 2 is not equal to 0, so we can't return 1, 2, 3. Okay, we can return either 1, 2 or we can return 1, 3. Okay, so in order to solve this problem, let's understand the logic first that we are going to implement in our solution. Okay, so this logic is going to be very important, so watch it carefully. Okay, I'm going to explain it very slow and in very detailed manner. Okay, so first of all, in this we have to find the largest divisible subset. Okay, so here before understanding this logic, okay, so I have one question to you guys. Let's say this is a subset. Okay, in this subset, first element, let's say 3. Okay, after that I am adding the element whose mod with the 3 is going to be 0. Okay, so let's say I have added 6. So what is 6 mod of 3? 6 mod of 3. Okay, 6 is completely divisible by 3, right? So the remainder is 0, right? So 6 mod of 3 is 0. And after that, so here one more thing, in this subset I am adding the elements in increasing order. Okay, so after that I am adding one more element x whose mod with 6 is equal to 0. So let's say I add 6, 24 here. Okay, let's say 24 again. So 24 mod 6. What is 24 mod of 6? So 24 mod of 6 is also equal to 0. Okay, because 24 is completely divisible by 6. Okay, so 24 mod with 6 is also 0. After that, here I am adding one more element. Let's say I have added 48. Okay, in this subset. So what is the 48 mod of 24? 48 mod of 24. So this is also equal to 0 only, right? Because 48 is also completely divisible by 24, right? So here in this list you can see that 48 is completely divisible by 24, 24 is completely divisible by 3, and 6 is also completely divisible by 3. But now here one more thing. So here, can this 48 is completely divisible by 3 by 6? Yes, it is true. 48 is also completely divisible by 6, because 48 mod 6 is also 0. 48, when we are going to divide 48 with 6, the remainder is 0. Now again check this 48 with 3. Okay, so this is also true. 48 is also completely divisible by 3. Okay, and can this 24 is completely divisible by 3? Yes, in this case 24 mod 3 is also equal to 0. Okay, so what did we get from here, from this step? From this step we get that we have to just check the mod of these two numbers, then these two numbers, these two numbers. Okay, we have to check the mod of the I plus 1 element with this I element. If their mod is equal to 0, then it is clear that its mod with previous element is also going to be 0 only. Okay, so this is how we are going to create one longest divisible subset. Okay, so I hope this is clear. Okay, so now let me erase this part. So now let's suppose this is array given to us. This is one array given to us in which the elements are 1, 8, 7, 4 and 16. Okay, so now to solve this problem we are going to first sort our array. Okay, because here we have to just return the largest divisible subset, and in subset elements order can be anything. It can be 2 1 1 2. Okay, it can be 8 4 2 1. It can be 4 2 8 1. So order can be anything. It will return return our output as correct only. Okay, so order is not necessary here because this is a subset, not sequence. Okay, so this is just a subset. Okay, so in order to solve this problem we are just going to sort our array first. Okay, because I have already explained one example in which we have to just check for the mode of the I and I plus 1, and if this is satisfied then it is definitely satisfied with the other elements. Okay, so that's why I am going to sort our array first. So here after sorting my array it is going to look like this. So these are the index, this is the index. Okay, and this is our array. Okay, so at 0 index element is 1, at 1 index element is 4, at index 2 element is 7, at index 3 element is 8, and at index 4 element is 16. Okay, so now we have sorted our array. After that, in order to solve this problem we are going to create one dp array. Okay, and in this dp array I am going to fill all the elements initially 1. Okay, so here I am going to create one dp of same size of this array, and I am going to fill all the elements with 1. Okay, so I have filled all the elements as 1, and after that I am also going to create one previous index named array. Okay, in this array initially I am going to fill it with the index only. So here see, this is 0 index, so here I have filled 0. Here the index is 1, so here I have filled 1 initially. Here this is 2, I have filled it as 2. Here it is 3, I have filled it as 3. Here it is 4 index, so I have filled this prev array as 4. So what this prev array is going to store later on? So this prev index is going to keep track of the last element in the dp that we are going to add at our particular index. So let's say this is dp of I, right? This is index, so this dp of I. In this dp of I, if I am going to add this element, this particular element, then I am going to store the index of this element here in this previous index. Okay, because here I am going to keep track how my dp is going to look like after I am adding this. Okay, so what did I add in my dp so that it is looking like this? What is the last element that I have added at this particular index? So it is going to just store the previous index that our dp has used at this point of time. Okay, so this is the use of this previous index. And also we are going to create two variables. One is max length, and we are going to set it to 101 initially, and we are also going to create one variable as max of index, and we are going to set it to 0 initially. Okay, now these are our first basic steps that we are going to perform in our code. Okay, that's done. Now after that, what we are going to do, we are going to run one loop which is going for I. So initially I am going to set my I at this 0 index. Okay, I is this at this index, and j is also at this index. Okay, j is also at this index. Okay, I am going to use one for loops. Okay, now for initially I am going to check for this condition. J is going to run till j is less than equal to I. So if both I and j are 0 for the first case, then there is nothing going to happen inside my loop. Okay, because my j is going to run till I less than I. Okay, so now let's skip this step, first step. Okay, so let me skip this step. Okay, so now my I is at this index and j is at this index. Okay, so now first I am going to check if my nums of I, if nums of I mod of nums of j. This is what I'm going to check. If my nums of I, that is this, okay, and mode of nums of j, so it is true, okay, it is true. And after that I am also going to check if the dp value, okay, if the dp value of at j is nothing but 0, so dp of 0 is 1. If dp of j, okay, this j, and when I'm going to add one more element in the dp, so this was the initial one, and after that I am going to add one more element in our dp, so it is going to be 2, and 2 is greater than the dp value which is available at this index, okay. So this is the initial dp, okay. When I am going to add an element, this element in the dp, okay, so I am checking what is the total count. Total sum is 2, okay, but here I store only 1, okay, so this is greater now, so here I am going to modify it with 2, okay. Here I modify the size of my dp of I as 2, because now the 2 elements are there in my subset, but 2 elements 1 and 4, 2 elements are there in my subset, okay. So I have modified my dp I as, that is dp of I as dp of j, that is 1 plus 1, so total it becomes 2. And here I told you that in previous index of I, this position we are going to store the j's index, so j's index is 0, okay, since this is using this value, okay, this value j value, so it is at index 0, okay. So here I have stored 0, okay. So I hope this is clear. Now after that my j, this step is completed, my j reaches here, and now j is less than I, so this is not true, so I have to skip this, so let me erase it, okay. So this is not required now, okay. Okay, so this is we are going to use later on also. So now my I reaches at this position, and now again my j is going to start from 0 to less than I, okay. J is going to run from 0 to less than I. So first my j is at this index, okay. So now I am again going to check if this 7 is divisible by 1. Is this 7 mod 1 is equal to 0? Yes, this is 0. And here I am going to check the frequency, it is 1, dp of 2 is 1 right now, but when I am going to add 7 and 1 together, then in that case this is going to become 2, okay. And this prev index is using this j value, so it is going to become 0, right? This is going to become 0. So this is for I when my I is at this position and j is at this position. Now after that what happens, this j moves to this index, okay. So now when j is at this index, then again I'm going to check if my nums of I modulus of j is 0. So 7 mod of 4 is 0. No, it is not true. So if this is not true, then we have to do nothing, okay. We need to skip this. Now this is completed. Now after that let me erase it. Now after that my I reaches at this index and j is at this index, first time, okay. So now I am going to check if 8 mod of this one is 0. Yes, it is true. So now I am going to add two elements, 1 and 8 both are added. So when 1 and 8 are added, so here I am going to update the previous index that 8 has used. So 8 has used this one now, so this one is at 0 index, so here I updated to 0, okay. So this is completed, j is completed. Now my j reaches here. Now I am going to check if 8 mod of 4 is 0. Yes, it is 0. If this is 0, then I am going to check what? I am going to check if the value at this index dp of 2, this is 2 now. When I am going to add one more element, that is 8 here, this was 2 previously, so when I am going to add 8 here, so it becomes total 3, and this is 2 given only, this is 2 here only. So when I am going to add this 3 here, okay, this is going to be updated to 3 because here I find one more element 1 4 and one more element 8. 148. Okay, so when I'm going to add 148, so here I have added total 3 elements at this TP of I, and here this 8 uses this index right now, this index 4, okay, to join the elements. So 4 is available at which j is 1, so here I have updated it to 1, prev is updated to 1, okay, prev is updated to 1. Now after that this step is completed and my j reaches here. So when my j reaches here, I am going to compare if 8 mod of 7 is 0. No, this is not true. Then we are not doing anything. Okay, so this step is completed as well. Okay, so now let me erase it. So now after that my I reaches here. Okay, so first time my j is 0. J is at this index. So I am going to check if 16 mod of 1 is 0. Yes, it is true. So this is 16 only. Now when I am going to add 1, 16, so it becomes 2. It becomes 2, and here j is going to be updated as 0 because j is using this one. Okay, j is updated to this 0. Now my j reaches this index. Then I am going to check if 16 mod of 4 is 0. Yes, it is true. And what is the size here available? This is 2 available, but now when I am going to add 16 also in 1, 4 and 16, in 1, 4 and 16, when I add this, then it becomes 3. Okay, so now it becomes 3, and here this is going to be updated to this index, 1 index, because I am using this 4. Okay, so I updated this 1, 3 and 1. Now my j reaches at this position. So now I am checking whether this 16 modulus of 7 is 0. No, it is not true. So I am going to skip this step. Then my j reaches here. Now at this index I am going to check whether 16 mod of 8 is 0. Yes, it is true. If this is true, then it is going to check for this dp of I value, this value. So in this value it was 3 elements before. Now I am going to add 16 one more. So it is going to update as 4 because now 16 is added here at this index 14816. So when 4 is added here, and at which index this 8 as element present is 3. So here I updated it to 3. Okay. So now from here one thing is clear that my dp is looking like this. Okay, so my dp is looking like this. First at this it is not 1, then 2, 2, then 3, then 4. This is how my dp is looking like, right? And my prev, how it is looking like that, how it is looking, it is looking like 0, then 0, then 0, then 1, then 3. It is looking like this, right? Okay, so my dp is looking like this and my prev is looking like this. Okay, so now what I'm going to do after that? So after that, see, this is an array given to us 1, 4, 7, 8, 6. So first time I'm going to add in the list of subset whatever available. So let's say I'm going to say it as subset. So in the subset, first I am going to add what? Max index. So here we are also going to keep note of what is our max length and max index after each step. Okay, so my max length finally it is going to update to this 4, and max index, at which index it is available? It is available at 3. Okay, so we are going to keep track of this one else as well. Okay, so this is the maximum length that I get 4, and this is the max index 3. This is max index, this is the max length. So first in my subset I am going to add the element which is available at the max index. So what is the element that is at max index? Okay, so at max index, that is this 3. What is the element? Okay, what is the element available at the max index? Okay, so here one more thing. First we are going to add the nums at max of index. Okay, so max of index is going to be 4. Max of index is updated to 4 only, and max of length is also going to be updated to 4. Okay, yes, so it is also going to be updated to 4 only. Okay, max of index. This is a pre-vary. This is pre-vary. Ignore it. Okay, so max length is 4 and max index where it is available, that is also going to update to 4. Okay, not 3, 4. Okay, so max index is 4 and what element is present at our max index? 16. So I have added this 16 in my subset. Okay, now after that I am going to check if the element at this, I'm going to check this element, because after that I am going to use 3 index. Okay, in this preview you see in the last step I get the 3 because this is the element that I'm using. So I'm keeping tracking of the elements now. So here I find the last element 16 that I've added, right? And here I give the link that I am using this third, these three elements. Okay, I am using these 3 elements. I'm using these 3 elements for this one. Okay, so I'm keeping the track. Okay, previous index. So I reached the previous index here 8. So I am going to add that 8. Now once I reached here, then I am going to check this one. Okay, what is the previous reference here? So it is previously referring to index 1. Okay, it is previously referring to index 1. So I am going to reach to my index 1. So what is the index 1? What is the element available at my index 1? So at index 1 element 4 is available. I am going to add it. Okay, after that I reached here. Okay, at this 4, and after that I am going to check the previous. What is previous showing? It is showing me to go to 0 because previous element that we have used till here is 0. So when I reach 0, so I have added 1. I've added 1. Now here once I reach this 1, then again it is referring to 0. So once element is going to reference to itself, in that case I am going to return. I am going to don't print anything. I am going to just break. Okay, so here what is happening? See, this is how our DP looking like. Okay, and we are also keeping track of the max length and max index. So max length, we are keep tracking of the max length in our DP. So what is the max length that we get? 4. And there is one more element, max index. Okay, so this max index and this pre values are different. Okay, this is not the same. So max index is going to show us at which index that we get the max length. So we get the max length at 4 index, right? At 4th index only we get the max length. Okay, so here this max index is 4 and max length is also 4. Then after that I am going to in my subset I am going to add the element which is at max index. So max index element is 16. Then I ask the 16 index. This 16 is available at 4 index. So I ask that prev index, that this is the array, this is the prev array. So I ask this prev that what is the value available for this index for you. So he said, this prev array said that for me at this particular index 4, this 3 is available. So I said okay, so now let me access this element which is at 3rd index available for you, available in the array. So I access this 8. So now 8 asks this prev what is the element available at this particular index. Okay, so prev said the one index is available. So array said that okay, let me go to 1. So it added 4 here. Now this 4 is going to ask that this prev array, what is the reference or the reference stored here. So it said that I took the element from 0. Okay, so my array going to pick this 1 and it going to add 1. Then 1 is going to check with this prev array. Okay, what is the reference? So it said 0. Okay, so you are just pointing to me only. So that is not the possible case, because in our problem it is mentioned that distinct positive integers are available. So we are going to just return it. Okay, so we have to just print this output 16, 18, 4, 1. Okay, so this is for backtracking purpose. Okay, so this prev array we are creating just for backtracking purpose. Now this is the complete theory that I'm going to write now in our code step by step. Okay, so if you guys are clear with the logic, now let's write the code. So first, as I told you, we are going to create one DP array. Okay, int DP, and the length of this DP is also going to be the same of our nums.length. Okay, nums.length. Now after that, I have told you that we are going to fill the elements in our DP arrays, that arrays dot fill where in our DP, and with which element? in our DP, and with which element? One element. Okay, so I'm going to fill every index in another DP as one. Okay, initially. And after that, I told you that we are going to use sort. So arrays dot sort, and we are sorting what? These nums. Okay, arrays dot sort nums. Now after that, I'm going to create one preb index. Okay, previous index, and in this same length, new int same nums dot length. Okay, now I've created the previous index array in which we are going to store the reference of the previous element that we have used at particular index of DP. Okay, now I'm going to create max length and max index. Max length, and I'm going to start it with 1, and int max of index, I'm going to start it with 0. Okay, that's it. Now after that, I'm going to run two loops. Simple. One is I and one is j. For int I is going to run from 0 and I is less than nums dot length, 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 and I plus plus. After that, inside this, I am saying that here I have told you initially that I am going to give the initial value as index only for the prev. Okay, here initially prev is 0 because this index is 0, prev is 1 because this index is 1, prev is 2 because this index is 2, prev is 3 because this index is 3. So initially I am storing values like this. So can I write it like this? Previous index at this particular I is equal to I only. Okay, so here I have initialized the values in our previous index. Now after that, I am going to run one j loop. For int j is equal to 0, I have told you j is going to run from 0 and j is less than I. Okay, that's it. So this is already cleared, right? Okay, so now this j loop, and after that inside j loop I am going to check what if the number which is at I mod of nums which is at j is equal to 0. Okay, this is one condition I am checking, and in the end I am also checking one more thing, that the element which is present at the previous index, that is dp of j, and when I'm going to add one more element in this dp of j, okay, once I find this nums I mod of num j is equal to 0, so once I am going to, after that I'm going to add that element into 1, so it should be greater than the value which is already present in dp of I. If it is less than, then we don't need to update it because we are already find the max size subset. But now if after adding this I we are finding if after adding this element we are finding one greater subset, then in that case we have to add that element. Okay, so if dp of j plus 1 is greater than dp of I, okay, so in that case only we have to update what. So I have told you that we are going to update the dp of I value. Okay, this dp of I value with the previous values if I'm going to add the dp of j plus 1. So can I write it like this? So dp of I is equal to dp of j plus 1, right? And I'm also going to update my previous index. Okay, I'm also going to update my previous index of I with my j value, previous value, because j is a reference to the previous value only. So this is clear. Okay, so I hope this is clear. This is what I'm doing here in this step. Once I'm going to use this element, then I'm going to add the size here too, and here it is going to point to the previous element. So this is what I'm writing here. So I hope this is clear. Now after that, I have told you that I'm also going to update this max length and max index side by side. So in order to update it, this is my if condition and this is my for loop. Okay, so now after that I am going to write one if condition, and in this if condition I am going to check if dp of I, okay, if this particular I is greater than my max length which is initially given as what, 1. If it is greater than this max length, then in that case what do? You just update this max length with the value which is present at this index dp of I, and also update the max index. And we are going to update max index with what? The value which is at a max length, where max length is available. So here again I am writing the wrong spelling. Okay, max of length is going to dp of I, and max of index is I, because this is a particular index where the maximum length available. Okay, so this is it. Now after that, now code is very simple. Okay, so here we have written one if condition, and this is where our complete for loop ends. Now after that, once we get everything, I am going to create one list, and this list is simply but subset where we are going to add the elements. Okay, so list of integers, this is a list of integers only, list of integer, and let's name this list of integers as subset, because we are creating the largest divisible subset. Okay, so can I create it name as subset? Yes, I can, and I will. Okay, subset. Okay, and then this is the array list, so new array list, and then close it. Okay, and after that, first I told you that we are going to add what element? The element which is available at the max index. We are going to directly add that element into our list. So can I write like this, subset dot add? But after that, the element which is present at the max of index. So the element which is present at max index, I am going to add this element into my subset, and then I am going to run one while loop. And in this while loop, I am going to check for the previous index array elements. So when previous index, I is capital, right? I is capital. Previous index, when previous index, the element which is available at max index. Okay, the element which is available at this max index. If this max index element is not equal to this max index, okay, if this is not equal to max index, then in that case we have to just update our max index, with which we are going to update our max index with the previous index of max index, right? Previous index of max index. This is going to be our new max index, and then we are going to add this element again, subset dot add, and the element which is present in the nums array for this particular new max index. Okay, so here that's it, and then in the end we have to just return the subset, return subset. Okay, so now let's run our code and see if there are any spelling mistakes or any code issues. So let's run it. Okay, so I see first spelling mistake. Nice. ARRAYS. Okay, next. Let's go next. Oh, nice. So all the test cases has been accepted here. Now let's submit our code and see. Good. So our solution is accepted. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing, and don't forget to subscribe my channel, like and share this video with your colleagues, your friends. Okay, and meet you in the next video. Thank you. Bye bye.